Hey, this is Martha DeGrasse here again for the Wi-Fi Alliance. And this is The Signal, our podcast where we bring you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. And today, we're going to be talking about Wi-Fi 7 and AI with Vineet Ganju. He is VP of Wireless Connectivity Products at Synaptics. Vineet, welcome to The Signal.
Thanks, Martha. Nice to be here. Thanks for having me.
Yeah, we're very happy that you could join us. I think it would be great if you could start off just telling us a little bit about the Synaptics solution portfolio, particularly Wi-Fi, and your role at Synaptics.
Sure, yeah, thanks. So Synaptics is a semiconductor company. As you know, we provide semiconductor solutions, especially for intelligent edge devices. And in the company, we have two major portfolios. One is in processing or processors. The other is in wireless connectivity. So we, as a company, we provide both processing and wireless solutions, as I mentioned, for intelligent devices. My role in the company is a wireless product manager. So I manage the product roadmaps, product marketing, go-to-market strategies for wireless technologies.
Okay, great. And give us a little bit of an overview about how Wi-Fi has changed your portfolio.
Yeah, so Wi-Fi 7 is, as you know, it's the latest Wi-Fi standard to be in the latest evolution of the Wi-Fi standards and is about to be deployed or has been deployed recently. Some of the cool things or the new things about Wi-Fi 7 that's really exciting is from a technology point of view that they're bringing the capabilities of higher throughput, lower latency, and higher density. So in our portfolio, we recently announced a new set of Wi-Fi 7 chipsets that take advantage of these new technologies.
Fantastic. And what are some of the new IoT applications that these can unlock?
Yeah, I mean, I think the benefits of these features that I mentioned, the higher throughput, the lower latency, and higher density, it can show up, in the existing applications that many people already use today, like in smartphones and set-top boxes and so on. But as you mentioned, it is unlocking a new set of applications, or at least a new set of capabilities for some newer applications. For example, take higher throughput, the higher throughput capability of Wi-Fi 7. When you think about AR or VR or mixed reality type use cases, those applications allow the experience to be more and more immersive. If you can have more video, more audio, or higher quality video and audio, that allows the person wearing the headset to really be immersed in the application. So that requires higher throughput of data going to the headset, which Wi-Fi 7 enables. So more immersive AR and VR mixed reality products. That's one use case. Another one that was driven by the low latency is the real-time industrial automation. You see these kinds of sensors, robots, machineries in smart factory and warehouses. That's not something you hear a lot about. It maybe is not as sexy as AR and VR use cases. But as factories get more and more complicated and more efficient, the ability to be able to send instructions to those robots or to the machinery, or have those machines talk to each other or talk to an access point, potentially using some sort of automated or AI system to control them. Being able to do that with very low latency so that you can send instructions to those machines and those machines can respond to those instructions very quickly allows you to have more precise and more efficient manufacturing. So we see that lower latency benefit play itself out in smart factories. And then the third thing I mentioned was higher density. So higher density means that it allows you to have more users or more Wi-Fi products in the same area, and they're able to coexist or exist in the same small space. So that's unlocking things like smart cities, like imagine having traffic management or waste management, environmental monitoring, things like that being all connected and all in kind of the same area. That higher density of Wi-Fi products is enabled with Wi-Fi 7 as well. So that's just scratching the surface. Those are just kind of three examples at a high level of some of the things that get unlocked with these new features and capabilities.
And even in our smart homes, we have space constraints and a lot of Wi-Fi devices all in the same place, right?
Sure. I mean, more and more, we see more and more of our devices in our homes get connected. Like no longer is it just a computer or just your phone. Right now, it's your printer and your robot vacuum cleaner and your set-top box and multiple TVs and all those sorts of things. So yeah, the density definitely helps in your home as well.
So we all know that the companies that sell these home devices compete on price, and some of them are pretty compact devices as well. So can you tell us a little bit about the challenges of bringing that high bandwidth Wi-Fi 7 to those space-constrained and cost-constrained devices?
Yeah, that's a great question because as you can imagine, as you go higher and higher in terms of capabilities or performance of a technology like Wi-Fi, normally you would think that brings higher cost, maybe higher power, higher, bigger area, which is generally true. Just in a brute force way, if you implemented this higher performance Wi-Fi technology like Wi-Fi 7, you would need, higher performance RF front-end devices like higher performance amplifiers, for example, that's able to transmit more data in the same amount of time. And so those front-end devices would take up more area, they would consume more power, which generates more heat, which means that you're not able to squeeze it into a smaller space. So those are the challenges of adopting this Wi-Fi 7 technology. But with some manufacturers, some chipset manufacturers, including Synaptics, what we do is we integrate some more of those technologies or some more of those components in the silicon chipset itself. So by integrating, for example, the switches in some of the front-end devices, not only does it make the area more compact so that you're able to take advantage of this technology in a smaller form factor device, but we're also able to do it in an efficient way so that it's not burning as much power, it's not generating as much heat as you normally would in a brute force way, which means that you can put it in a more compact form factor and not have to worry about over temperature problems.
So that's probably really valuable to those IoT device makers.
Yeah, that's super valuable to the IoT device makers. And the other thing that happens is when you compact these technologies into a smaller space, typically, with these Wi-Fi systems, you have Bluetooth technologies operating in the same product. So then you end up with coexistence problems of Wi-Fi and Bluetooth trying to operate on the same bands. So that's another reason why device manufacturers such as Synaptics, we integrate the Wi-Fi and Bluetooth on the same device and manage the coexistence with, Synaptics particularly known for coexistence management between Wi-Fi and Bluetooth, for example. And even doing things such as like sharing antennas or sharing RF front ends between those devices allows you to even further reduce the space and area requirements.
Okay, that's interesting. Aside from Bluetooth, what about other protocols? Thread, Zigbee, even Matter? Are those also integrated on the chip?
Yeah, that's a good question. I mean, as you mentioned, the smart home is one of the applications of Wi-Fi 7. And in your smart home, you have these emerging standards, home networking standards, like you mentioned, Thread and Zigbee, which are more meant as a low data rate standard that just allows, minimal data to move between sensors, for example. It's not really meant to transport video or audio or things like that. But it is becoming more and more used in things like thermostats and, window sensors and very low power and low data rate products in your home. And so what we're seeing is product manufacturers who normally had Wi-Fi and Bluetooth in their products are looking to add Thread and Zigbee support in those products as well. And Thread and Zigbee use a technology called 802.15.4, which operates on the same band, 2.4 gigahertz band as Wi-Fi and Bluetooth. So being able to integrate those in the same device, in the same silicon product, first of all, allows you to save area because now you don't need a Wi-Fi and Bluetooth chip, and then you need a separate Thread and Zigbee chip. By combining them all into a single chip, you save area on the board. Secondly, it allows you to manage the coexistence, like I had mentioned, with Wi-Fi and Bluetooth. Now you have a coexistence challenge with Thread and Zigbee also operating on the same band. So having all those technologies in the same chip allows you to manage that coexistence more intelligently. And third of all, maybe one of the biggest issues is the software complexity, that if you have software as a product developer, application developer, your software is managing a Wi-Fi device. And now if you also have to separately manage a Thread device and Zigbee device and have all those things talk together and work seamlessly, it's very complex from a system point of view. So having them all on the same device, having them already pre-optimized to work together, having a consistent software interface to the software developer to manage them, that's a huge benefit as well in terms of complexity and time to market.
Sure. I feel like it's going to get even more complex, though, as more of these devices are doing AI and processing on the device, right?
Yeah, exactly. I mean, that's a good point. So we mentioned that the IoT sort of started with this idea of a low power sensor, and it was just constantly sending data, even at a low data rate, constantly sending data from the sensor back to a hub or to the cloud for intelligence processing. But you're right. I mean, the kind of what we learned over the last 5+ years is that all that happens is it's just a lot of data that's going and a lot of cloud processing and cost that's going into processing that data. So what a lot of companies have realized over the last several years is if you can put that intelligence, some limited amount of intelligence in the sensor itself or closer to the sensor, maybe somewhere in your home in a hub device, then you're not sending, tons of data to the cloud and consuming the power and cost associated with that. So as you said, you're putting AI processing more locally on these devices in your home. It also helps with privacy as well, because a lot of the data from your home doesn't leave your home. It gets processed locally. But then the challenge, as you said, is now you have more things happening in the product, more processing, which requires more power, which generates more heat and so on. So as you add AI processing into these devices, the area and the power and form factor constraints become even more challenging.
So are these GPUs in these devices, or are these CPUs doing the AI processing?
It could be CPU if it's very low amounts of processing, or if the AI is not running very often. It could be a GPU, or even, what we call the NPU, or a neural network accelerator, which is specifically only meant to run neural network models, whereas a GPU could run both graphics processing or neural network models. So yeah, it could be any of the above, depending on the requirements of the product. For example, let's say you have a smart thermostat and it's got a display on it. So maybe you want a GPU, a graphics processor, to be able to output the graphics onto the display of that thermostat. And that same GPU could also be used for neural network processing as well. But if you have a different type of device that doesn't have a display, maybe doesn't have the need for a GPU, could use a CPU or a neural network processor to do the AI processing.
Okay, that's a good explanation. So those are showing somebody what's going on with their thermostat graphically. That's a consumer AI application. But then I think AI is also useful for managing the Wi-Fi connectivity, right?
Yeah, I think AI and connectivity is a pretty hot and just in its infancy, a topic that's just in its infancy in the last year or two, I think. But there's a lot of potential. I mean, we could all discuss or agree or disagree on, whether the AI is purely hype or, there's a lot of benefit to it, or maybe I should say it's overhyped or not. But the reality is, I mean, it does provide a tremendous benefit in some applications, in some use cases. And I think Wi-Fi is an example of where I think there's a ton of potential that's still yet to be explored with AI. For example, some of the uses in AI or in Wi-Fi or connectivity in general, think about network performance or network management, being able to dynamically allocate resources depending on the type of traffic, whether it's video or audio, or whether it's real-time sensitive or not real-time sensitive. You can predict whether it's high traffic load is coming, and you can do things in the network to mitigate that. So just in the network management alone, there's a lot of potential. Another area is in security, connectivity security. That's sort of been in the news lately. You may have heard or read about these security cameras where there's these attackers that can jam the Wi-Fi signals of the camera and then basically render them useless. Like they're able to record, but they're not able to send out anything that they're recording over Wi-Fi. So being able to use AI to detect attacks, to mitigate, to send a message to somebody that attack's coming or attack's happening or so on. And those are things that AI can be used for in security, also access control and things like that as well. So there's a lot of potential for AI and security. And just in general, like improving the user experience. Some of the companies we talk to that deploy these smart home products to end users, they said one of the biggest challenges is the setup, like the installation. Like you get a box on your front doorstep of whatever it is, security camera, a thermostat, or a light switch or whatever. And then you want to install this connected product in your home. And a lot of people, they turn it on, follow the instructions, and the first thing that happens is you can't get connected. Like it's not connecting to your Wi-Fi network. And so you're kind of stuck. And what happens is those users will call the company. So that's an expense for the company in answering the calls, potentially sending out an installer or a truck. So that's expensive. Now imagine if you had an AI engine in that product that had a local speech recognition that enables a local virtual assistant on that device. So even if it's not connected to the Wi-Fi, even if it's not connected to the network, from the moment you plug it in, you can start asking it questions like, why are you not connecting? What's the issue? What can you troubleshoot this for? Yeah, why doesn't this work? And having a virtual assistant talk you through and say, oh, it looks like we haven't selected the right network, or the password wasn't accepted, or something like that. And it could literally walk a person through in an interactive and dynamic way how to set up their product. And that would be enabled with the AI running locally in the product itself. So that's just one example of being able to utilize AI in connectivity. A lot of the challenges with these devices are getting them connected. Once they're connected and online, then you can do a lot of other stuff, capabilities to help manage and do firmware updates and so on. But just getting them connected using AI to do that can be a big deal.
Yeah, I think everybody's experienced that. What about Wi-Fi sensing? That's one use case we haven't talked much about yet.
Yeah, that's a great point. So sensing is a big one these days also. I think, for example, I have a thermostat in my home that when you're not close to it, then the display dims or turns off, doesn't show the temperature or anything. But as soon as you come within, let's say, 3 or 4 feet of the product, then it wakes up, shows you the temperature, gives you the controls to adjust the temperature and so on. So that's a sensor that's detecting the presence of a person and detecting not only that a person is present, but, how close they are to the device. And today it may use technologies like a PIR sensor, or maybe some of the more sophisticated ones will use a radar or a UWB type implementation. But some of that stuff can be done with Wi-Fi signals as well to a certain extent. So being able to sense the presence of people or things, like animals and so on, that could be an emerging use case for Wi-Fi as well.
Okay, all right. What about fusing a lot of these together on one chip, Wi-Fi and AI and sensors? Is that something that can all fit on one SoC?
Yeah, it can definitely fit. I mean, as we talked about before, that these sensors started out as just doing sensing and very low data rate. Data was sent back to a hub or to the cloud. And then as we talked about, the evolution was to do more intelligence in the sensors or in the hub devices. As they continue to evolve, those sensors can have, more rich data, which requires a higher bandwidth connection to a hub, and both could have AI integrated. So basically all this sums up to mean that having a solution that integrates the sensing capability and the connectivity, Wi-Fi connectivity, and the AI processing is becoming more and more needed these days. And as we were talking about earlier, integrating them all into a single chip has a lot of benefits in terms of area, in terms of system cost, in terms of design complexity, software complexity, and so on. So that's absolutely an area that companies are moving towards, including Synaptics, having this all integrated into a single chipset.
Okay, great. We talked a little bit about security in the context of cameras and connected cameras, but I feel like it's one of the most important topics around Wi-Fi right now, and being able to dynamically update security over the air. What are you doing in this space?
Yeah, so I think over-the-air updates, sometimes people ask a lot about why they have to connect their smart home devices. Like I bought a fridge or an oven or air conditioner or whatever that has Wi-Fi built in, and why bother connecting it? Because, I don't need it to update the time or whatever. I can just do that automatically. But I guess the hidden reason, which most end users don't know about, is that those devices, one of the main reasons for their connectivity is to be able to update the firmware, not only to be able to update the user experience and features and correct bugs, but also to be able to provide security patches. As new capabilities and new security threats come along, you want the ability to continue to improve the security resistance to those attacks. So yeah, for sure, we provide the ability to update the firmware over the air with these Wi-Fi chipsets or these connected chipsets. And actually, the interesting thing, going back to Wi-Fi 7, with the capability of higher throughput of Wi-Fi 7, you're actually able to push these firmware updates faster, right? So you can do bigger updates faster because of the higher throughput of the Wi-Fi. So that allows product manufacturers potentially to do more complex updates or do them more frequently, because the user doesn't have to wait now, 30 seconds or a minute or 2 minutes or whatever for the firmware to get transferred into your device and reload it. Now it could happen much faster. So that Wi-Fi 7 even provides a benefit with these over-the-air updates as well.
Saves us 2 minutes. All right.
Yeah. 2 minutes. Yeah, they add up, right? Those 2 minutes add up.
Yeah, they do. They do.
Yeah.
All right. Well, these 20 minutes with you have been really informative. Thank you so much. Is there anything else that you want to share while you're here, Vineet?
No, I think we hit all the major points, Martha. Yeah, I think, as I said, Synaptics is investing heavily in Wi-Fi and this Wi-Fi 7 portfolio we just launched a few months ago. We see a lot of great interest in it. And I think we've already seen products in the market in the mobile space using these technologies, and we'll soon see products in the rest of the IoT smart home type of applications. So we're excited for the users and listeners to be able to see and hear about those products as they come out.
Okay, right. Well, we'll have to have you back in another 6 or 8 months to get an update.
That would be great. Yeah.
All right, Vineet Ganju, VP of Wireless Connectivity Products at Synaptics. Thank you so much for being here.
Thanks, Martha. My pleasure.
And that is our show. You can get the signal straight to your device through Apple Podcasts, Spotify, Amazon Music, or of course through the Wi-Fi Alliance. That's y-fi.org. I'm Martha DeGrasse, here for the Wi-Fi Alliance. Thank you so much for listening. Join us next time on The Signal.